right. Well, thank you much. I appreciate you all letting us present on this evening. So I'll probably do the majority of the talking, but Ben has he was really instrumental in kind of pushing our environmental benefits that we got out of environmental pool management, which is a way of managing the pools on the upper Mississippi River that are managed by the St. Louis district to promote aquatic and emergent vegetation. So I'll just be kind of giving an overview of kind of the core locks, the way that they're managed, and then really focus on environmental pool management and the results that we've been able to achieve out of that. Really over the past, it's been going on since 1994. So, all right, and pardon me. Okay, let's see if it's gonna switch. Sorry, little technical difficulties with the screen share. There we go. Let's see if that one's going. There we go. Sorry about that. All right, so this is a side profile of the locks and dams on the upper Mississippi River. The reason I kind of show you this is we're really going to focus on the far right of this diagram, the St. Louis district, and lock and dams 24 through 26. That's where we've been implementing environmental pool management since 1994. I think this is kind of a nice diagram for kind of showing when the flows are low on the Mississippi River, it kind of creates this water elevator for navigation purposes. The locks and dams aren't for flood control, so there's no storage within the locks and dams. So when there's high water, the flows actually follow the profile of the river channel itself, like they would have historically. It's at those lower periods where you start to see that kind of staircase effect with that, and that'll be a kind of an important factor as you kind of consider how those locks and dams are managed to maintain a channel for navigation, and then how we can kind of pull in some of those kind of modifying the management to promote aquatic and emergent vegetation on kind of the periphery of islands and on the channel borders. Okay, and this picture here will show this kind of includes all of the watersheds that kind of drain into the area managed by the St. Louis district. And so what we're going to, like I mentioned, we're going to kind of focus on that Lock and Dam 24, which is up in Clarksville, Winfield Lock and Dam, and in Winfield, and then Mill Price, which is in Alton, Illinois. And then more recently, we've also implemented the environmental pool management principles on the Kaskaskia River Basin, which is that pink basin that kind of juts out to the northeast and includes a lock and dam essentially right at the confluence of the Kaskaskia River and the Mississippi, and then also includes Carlisle Lake and Lake Shelbyville. And so that one has just started to be managed kind of together as a system to implement those principles. All right, so environmental pool management. So I mentioned, with the locks and dams, the primary authorization when they were constructed was to maintain a navigable waterway for barges and recreation. And so environmental pool management, it kind of takes advantage of opportunities where we can kind of work within those constraints to promote vegetation. So if conditions don't allow modification of the dams to promote the vegetation on the channel borders, we have to focus on the navigation on that. So that takes priority. So there'll be periods of time where it's kind of out of our control, and periods of time when we can make adjustments and try to get these greater environmental benefits. And so I mentioned at the beginning that this really started back in 1994, And so annually we have a big coordination meeting with all the state and federal agencies, the nonprofits that work on the upper Miss in the St. Louis district. And at that meeting, there was a biologist from the Missouri Department of Conservation that asked if we could consider essentially having a half-foot drawdown for at least 30 days. Just try that and see what the response might be. And our water control office thought that would be manageable. You can see kind of a sample hydrograph from that 1994 period. This is in pool 26. And there was a drawdown for about a half foot for a little over 30 days. And what really came out of that was there was a really strong emergent vegetation response in there. A lot of annual emergent vegetation that's really provides a lot of high quality seed for waterfowl. And that type of practice, so that was coordinated heavily with all the agencies, and kind of became the standard practice for about the next 20 years. And then in 2014, it was just kind of the way that the flows were coming down the river. There's high enough flows that the drawdown could occur for an extended period of time. And we had a strong response in some of the perennial vegetation. And I think Ben was one of the first people to kind of take note of this. And we also had some input from the Nature Conservancy. There was a biologist up there, Gretchen Benjamin, who worked on a lot of aquatic plant communities up in the upper Miss and the headwaters, and worked with drawdowns up there as well. And she came down and was talking with the Corps and others, and asked if we could consider doing a longer duration drawdown to promote not just annual emergent vegetation, but also try to recover some of that perennial aquatic component. So things like arrowhead and lotus beds and those sorts of plants that had largely disappeared after the flood of '93. So there were several areas that they occurred prior to '93, and then after the '93 and '95 flood, they kind of they were on the decline until the point that they just weren't really found in many areas. And so starting in 2015, we started to look at doing a longer duration drawdown of at least 90 days if it was possible to do so. And then went out and monitored the kind of the results from that. You'll see here a picture on the far right, the upper right there is Ben on, I think that was up at Farr's Island actually. And you just see, there's a lot of nutrients, really nutrient-rich soils, and the nodding smartweed that's probably 6.5, 7 foot tall in that area. But in addition to the monitoring that the Corps did, we had a lot of input from the state and federal agencies. So MDC, IDNR, Fish and Wildlife Service up at Two Rivers National Wildlife Refuge, that we would have weekly calls, and essentially we'd get kind of on the ground feedback of what conditions were like at that time, and then water control could kind of share what kind of flexibility they had in their management, and if we could attain that. And so that's been kind of just the standard since then. So it's been weekly calls during the growing season when we can be doing that environmental pool management period. And so now we'll kind of transition into how the locks and dams are managed. The drawdown seems simple to kind of just lower the pool for a little bit, but it's a little bit more complicated than that, and certainly more complicated than I can with it. We know we have a lot of engineers that are modeling different conditions on the rivers, the inputs from upstream, and prescribing different elevations at a given time to make sure that they can maintain that navigation channel. So there's two primary ways. There's dam point, which is essentially you're kind of keeping a target elevation at the lock and dam itself. And if the flows get high enough that starts to creep up, then you open up the gates and kind of maintain that level. At hinge point, and that's a little bit more complicated in that you have a control point at the lock and dam, but you also have, so at the lock and dam, there's a range which the values can be managed within, and then an upper and lower limit. And then at the hinge point, which is some distance upriver, so at Grafton, that's a little over 8 miles upriver, there's another control point. And so you essentially have to keep within the upper and lower bounds at both of those points. And depending on the flows, that kind of controls what that profile of the water looks like. And so in this figure, when there's very low flow, you essentially get this flat pool, which is like that staircase effect that was shown on that first diagram. And under this condition, you know, it's just the gates are mostly closed. There's very little water flowing through, and it's just a constant elevation from pool 26 all the way up to lock and dam 25. And the pool is just that area between the two locks and dams. And you'll see on the figure on the right, there's kind of the red band on the outside. So that's the flowage easement. So that's an area that we essentially when we have to kind of maintain it within that boundary, with the exception of when there's floods where there's just nothing that can be done to kind of keep it within that boundary. And then as you go from that lower flow period, as flows start to increase, you're essentially, in order to keep the water between the upper and lower bands at the lock and dam, as well as the hinge point, you're opening up the gates, and it essentially puts the pool on tilt. So you have a decrease in the elevation on the lower end of the pool, while that elevation at the hinge point is actually kind of creeping up a little bit from the previous diagram. And when this occurs on the figure on the right, you'll see that kind of tannish color zone. So this is the zone that is exposed during just along the fringe. So that's an area that can be actively managed for environmental pool management. Yeah, and you'll see it on this one here, the green zone there. All right, and then as the flows coming down river increase even more, you're pulling the gates out of the water at the lock and dam even more. It's kind of causing a greater tilt of the pool overall. And so you have a decrease at that lower end of the pool again. And so there's another zone that is exposed under this scenario. But that's an area that we don't actually manage for the environmental pool management, because there's a lot of fluctuations as those flows change. We kind of toggle back and forth between those higher flow and lower flow periods. So you go from a pool on tilt to a flat pool and back and forth kind of thing. And then this is just to kind of illustrate what it looks like when the open river condition is essentially a flood, where there's the gates can't be opened anymore to kind of maintain the water elevation between the upper and lower limits at the dam and hinge point. And so the river is running as it would otherwise, and that's when it kind of spills outside of that easement period where we can't control it anymore. All right, so this figure here is an example hydrograph, and you'll see the green bars on the screen. Those are kind of the actively managed environmental pool management areas. And so what we do, I mentioned that there's that kind of transition between those higher and lower flow periods, and that kind of changes how the pool tilts or kind of flattens back out and kind of refloods area, or not refloods, but kind of re-inundates areas. And so in this figure, you'll see the blue line is the actual elevation of the pool. The orange line is kind of that maximum level that if you were on the upper end of the limit at those control points, that's where it would be. And so when we're trying to manage for the environmental pool management, we're kind of trying to hug that lower limit. So we're still maintaining a navigable waterway, but we're kind of hedging our bets for when the flows taper off, that we can keep it a little bit lower, so that as vegetation is establishing, it can kind of withstand being re-inundated as the pool is coming back up.
Hi.
All right. And then, so there's a lot of different benefits that come out of environmental pool management.
Right.
One of the main ones is that as you know, these areas, backwaters that would be flooded for long periods of time, they have flocculent sediment, that really loose sediment that kind of sucks you into your hips, makes it, it's difficult for a plant to establish in under those conditions. As those areas are exposed for longer periods of time, you get some of that soil structure is restored, and it firms up enough that plants can establish back in those areas. And you can see in the upper two pictures kind of the two extremes of that. The one on the right was just exposed and you're sinking, and on the left there, this was an area of backwater where there's some duck blinds, and there's actually a truck that could drive back there on that area where, in previous months it would have sunk right away. The other piece of this, with those kind of extended drawdowns, you're really allowed, or really able, to get different transitional areas established. So you're able to have that open water, mud flat, emergent vegetation, aquatic plants, shrubland, all the way up to your early successional forest, kind of establishing and then transitioning into the fully established floodplain forest. Without that environmental pool management, the water would be held high, and you essentially have an open water condition that transitions more quickly into that floodplain forest. So kind of have a reduction in habitat diversity out there. And so for this one, I was just going to run through a quick time series just to kind of show kind of what it kind of typically looks like on a year. I say I have the open water here in mid-June. About a week later, it's starting to be a drawdown, just water at the surface. And about 5 days after that, you're starting to get some germination on the upper band. And then by early July, so just a couple weeks after it was first exposed, you have plants that they were establishing, they were putting on a lot of growth, and then they're kind of flooded and set back a little bit. And then another 2 weeks from that reinundation, and it's really greening up, filling out. By about a month of exposure, you're at about 2 feet tall, and probably 3 feet in another few weeks. And at that point, the mill we have in this picture, there's a lot of millets are filling in the area, and they're starting to seed out, which will be really important foods for waterfowl. You'll see water that's starting to, as the water level came back up, the plants are still actively growing because they're mature enough to withstand that kind of reflooding. And then later on, that's going to provide fuel for developing macroinvertebrates for fish and migratory waterfowl in the spring that are needing those high protein sources. So, all right. So the overall impact of environmental pool management. So this was something that Ben had kind of coordinated this for the LIDAR for the Mississippi River. So pools 24 through 26. Kind of had the LIDAR data gathered at a low water period, kind of where areas were fully exposed. And this is a very conservative estimate that 800 acres would just contain that zone that was actively managed. But we know by looking, through the surveys and such, that there's plants that do grow below that actively managed zone, so they benefit from the drawdowns, because we're kind of stitching together different periods that might be more have greater exposure for parts of the year. And then the lower picture, that's from the Kaskaskia River system. So that's where we've also added these principles to there. And we used aerial imagery collection at the normal elevation and at the drawdown, a 1/2-foot drawdown at each of the locations. And for this one, our kind of conservative estimate is 2,300 acres. On the lower Kaskaskia, that's I think a pretty significant underestimate. At Carlisle and Shelbyville, I think that's more realistic. Now, not all of that exposed acreage is suitable for establishing. So if you have riprap or loose sand, you're not getting the plants established in those areas, but that's kind of the total acreage exposed. All right, so we use a number of methods for evaluating the plant response. One of them is using the CTAP protocol, the transects protocol that they use. So you kind of run the transect a perpendicular across the wetland and take a bunch of quarter-meter plots along that transect to sample the vegetation. And we use a couple other methods as well, some more qualitative than others. And in general, I'd say, across the pools, we typically get 30 to 50 species that grow in the backwater areas. The number of species kind of depends on the year, the type of drawdown, and the duration. And then how much variability occurs between the pools. So sometimes one might have a late season drawdown that promotes certain species, while an early season drawdown promotes others. And then with just looking at individual backwaters, that's usually about 5 to 15 species are the main species that make up the plant communities in those areas. And so I'd say it's with this longer duration management, our dominant species are the smartweeds, millets, brangletop, and flat sedges. Many of these, like I said, are really great plants for migratory waterfowl. And that's something that we've kind of looked at because of the importance of the area on the Mississippi flyway for migratory birds and migratory waterfowl. And then some of the perennial species that have responded to these longer duration drawdowns is arrowhead, which I'll kind of talk about in a little bit greater detail because we've had a really nice response in that one, as well as lotus. And then though the other species I did want to point out is depending on the season and conditions, we've also had decurrent false aster established in a number of those backwater areas. So that's been, and that one's a federally threatened species. So that's a kind of a cool one for us to see on that one, on the areas below the Illinois River confluence. All right, so this one is kind of looking at so there's an area in so this is in mile 210 where that time series was taken, looking at the arrowhead response to those longer duration drawdowns. So and over that 3 or 4 year period, it had steadily increased in size and distribution out there, from fairly small clumps to covering a pretty extensive beds in a lot of the areas that had occurred historically. Then in 2019, we had a historic flood that was a really long duration flood, pretty similar in that duration to like the flood of 93, high magnitude one. And that really set back the arrowhead beds at that mile 210 area. So at the end of 2019, in late September, there was just a handful of arrowhead plants that were actively growing. And then in 2020 and 2021, it started to build back with longer duration drawdowns occurring again. And then by 2022, this was taken by a drone. We got some video and photographs of the mile 210 area, and the area that's outlined in white, that's kind of outlines the extent of the arrowhead beds that had established and patches that established there. And that's about an acre where it makes up the dominant species within that zone. So that was a pretty neat response to see. And then I had mentioned this early on, but with these longer duration drawdowns at the upper end of the upper elevation areas, we are starting to get a fair amount of cottonwood and willow species establishing in those areas, and that's something that is on the decline in the upper, at least on the Upper Miss and St. Louis district. It's one with where the way that the locks and dams have been managed, there's fewer of those kind of highly disturbed areas at the edges that, with high sunlight, mineral soils for the species to establish. And so I think the environmental pool management has kind of given an opportunity to kind of help expand some of those communities. And both of them are important pollinator plants in the early spring. And, cottonwood is a really important structural tree for raptors and eagle nesting, colonial water birds, the endangered bat species that occur in our area, as well as many others. So, and then I mentioned kind of that wide gradient where you're promoting a lot of different vegetative diversity. We have a number of, a lot of different plants that are flowering at different times, and so that's also providing some pollinator habitat that wouldn't be there otherwise. So, and then this will be the final kind of method of sampling that I'll share with you. And this is kind of related just to the importance of the area for migratory waterfowl. But we essentially did some seed head analysis out there. And that this occurred in 2016, 17, and 18. And I'm going to share an example from 17 because it's kind of an average year. So this was one that it was about a 60-day exposure, which is about the minimum length that would typically need for a lot of those emergent plants to produce seed. But with that, it was averaged about 1,300 pounds per acre, which is a really highly productive wetland system. So that's on par with what the refuges would achieve in highly intensively managed units. And so it's pretty neat to see that, this is something that it doesn't require additional cost by the Corps to modify the way that the locks and dams are managed. They have to make the gate changes anyway. And so this is pretty neat to see that great of a benefit out of just kind of changing a few things here and there. So with that, so with that, I kind of wraps up the slides that I had, but I wanted to leave it open for any questions or comments that anybody had. You're welcome to raise them now.